Hello, friends. Welcome to the Georgia Tech AI podcast. My guest today is Maithili Patel. Maithili is a robotics PhD student at the Georgia Institute of Technology. She's advised by Professor Sonia Chernova, focusing on proactive robot assistance. Today, we'll explore how robots can be better assistants in our day-to-day household tasks. Observing our human routines, our preferences, our schedules, and understanding when exactly robots should intervene to be better collaborators in our day-to-day lives. Maithili has a lot of experience in the robotics arena. She's worked at the Toyota Research Institute on autonomous driving technology. She previously held an internship at Meta and the Allen Institute of AI. She was named an HRI Pioneer in 2023. She holds a master's degree in mechanical engineering from the University of Michigan and an undergraduate degree from the Indian Institute of Technology. Please let me know how I can improve, and I hope you consider subscribing. Thank you very much. I wanted to start off with asking you about a fictional character, Rosie the robot. What inspiration have you gathered from this character in your research?
Well, Rosie the Robot, for me, as a 90s kid, is just something like I grew up with. So it's close to my heart and all of that stuff. But I think really it was that long ago, and yet that character had this kind of way of interacting with people that was very natural, that was not quote unquote robotic. And I think that's kind of the primary thing I get from Rosie, that people shouldn't have to adapt to robots, which it's gotten better over time. We don't need programming languages anymore to be able to talk to robots. There are robots that we can talk to in natural language and simplify interfaces, but everything still feels quite robotic. So I think, the primary thing that I get from a robot like Rosie, many other examples at this point, but the primary thing is that you can talk to it in like a normal human way.
Yeah, absolutely. There's this whole point about the two key components that you had discussed in terms of creating a user-friendly robotic system: proactivity and personalization. So could you talk more about each of these?
Yes. So when I say robotic commands, let me explain that a little bit. What I mean is back a couple decades ago, if you wanted to get a robot to do something, you'd have to write code. There was no other way around it. So that's what you meant by experts, that experts were people who would write code to then operate a robot. Today, that has gotten simplified much more. So you can talk to robots or operate robots in natural language. So in English, you can ask a robot to be like, can you bring me a pencil from that desk? Assuming the robot has some notion of that desk, and place it on this table again, assuming the robot has this table. So we've gotten to that point, but imagine you have a robot that you can use with this interface, and now you're trying to ask it to make you breakfast, right? It's going to, assuming it knows where everything in your house is, it's still going to look like, go to the fridge, open the fridge, find a crate of eggs, take an egg out, put it on the counter, right? It's going to be so that's what I mean by robotic. It's not necessarily the modality of the interface, but it's the specificity and the level of detail that you need to talk to this robot. But the problem is you need this detail, because how else is the robot going to get all this information? So the answer is, if this robot lives with you, it should be able to learn something about you, and it should kind of complement the information that it's getting from you with the information that it already has about you. So how do I like my omelet? I like it with vegetables and cheese on top. Every morning, do I have breakfast? Yes. So if it knows these things, then it just takes away the burden from the user of specifying all the detail. Now, how that brings me to the particular components of proactivity and personalization there's two ways you can reduce this detail. One, for very routine tasks, like I have coffee every morning. I shouldn't have to tell the robot every morning to be like, bring me coffee, bring me coffee, bring me coffee. So the first component is proactivity, which comes into play because you have some of these routine activities that are happening so consistently that you shouldn't even have to tell the robot anything. And the second idea of personalization comes into play because there are some of these details that I like sugar and cream in my coffee, or I like my omelet to have 2 eggs and vegetables. And most of these things are slightly variable, but a lot of these things don't really change. I have some preferences that are going to that are going to continue to exist. So if you take away the need to give the robot all of these preferences, then I can just be like, hey, prepare an omelet for me. And now the robot's like, okay, I know I need 2 eggs, I need vegetables, I need cheese, and I'm going to do this. So yeah, the 2 ways come because for routine activities, you don't need to say anything. And for personalization means you can take away a lot of detail from your commands to the robot.
Yeah, I keep forgetting that I need to make breakfast, and I always wake up too late, and then I don't eat breakfast. So I would really appreciate a system like this. What can you conclude about humans? It feels like we're very routine creatures, but there's also some degree of stochasticity or unpredictability. How do you account for those two things?
Right. Yeah, that's yeah, I think everyone's like certain degree of routine creature, and I choose to believe that people overestimate how noisy their lives are. We really do have routines, and people take that for granted. But yes, I do agree. There's some level of stochasticity. So at least for that comes into play mostly for proactivity work, where I don't think that robot should be able to read your mind, right? I think if I had a proactive robot which got its prediction correct 100% of the time, I would be creeped out. Like, how did you know before I knew that I wanted yogurt for breakfast? So no, I think that's creepy. So I think proactivity needs to understand the patterns that there are in your routines, but also needs to understand the stochasticity that there is, if that makes sense. So maybe the pattern in my routine is that I have breakfast every day, but the stochasticity might be that I have an omelet for breakfast and sometimes I have a yogurt for breakfast, or sometimes I have something else for breakfast. And that just depends on my mood and factors that are not observable to anyone except me. So I think the only way really to account for that is to just ask the person. So at the end of the day, we need a robot that understands patterns, understands the options it has to then kind of start an interaction. To be clear, I wouldn't promote a proactive robot that has no interaction and just keeps doing things. Even if it gets things right, it's just kind of slightly unsettling. I think where proactivity comes in is I think you still need to predict these user behaviors, because without a guess of what could happen, there's really nothing you can do. But once you have a guess or a set of guesses, you can ask the person, you can ask for permission, talk to the person, remind them. You can do a whole lot of things. So I think where we are right now is kind of the step one of, can we even predict?
Yeah. How do you avoid annoying the user? This is something I kept thinking about. If I'm always gonna rely on interactive querying when I'm confused, when is it too much?
Right. So whenever we make verification mechanisms, we always make sure that we limit the number of queries that are asked per person once every n minutes or n queries a day, right? So there's going to be some kind of heuristic approaches to doing that. So the research question there is always, how do you maximize the amount of information you get with the query allowance you've given to the robot? So you'd always set a threshold, and then in a real robot, you'd have that to be tuned. You'd have that the person have the ability to tell you that, oh no, that's too, or that's against me more. I'm okay. So I think realistically, that's how you do it.
Yeah, and through your papers, I keep hearing on this theme that it's unobtrusive observations and also proactively assisting them without being too overbearing. I wanted to talk about the question of agency. You mentioned this point. Who does the task? Sometimes it might be that the human prefers to do the task. How do you know when is the perfect time for the robot to intervene?
Right. I think, yes, that is a very important point. We don't want robots that take over our lives. I don't want a robot to literally be in my place. So yes, I want agency over some tasks, and the robot should not be doing everything that a person does out of the box. I think that is a complicated question that includes agency. There are other reasons why the robot should not be doing things I do. There could be safety reasons. There could be just general preference reasons. Like, I like making my own coffee. I don't want the robot to do that. Maybe my neighbors don't, right? Like, maybe my neighbors hate coffee and want their robots to do that every day. So I think that is another kind of, at least I treat that as a preference learning question. The person should have the ability to tell the robot that these are the kinds of things that I want you to do. but these are the kind of things that I don't want you to do. So that was actually a follow-on work. And the kind of gut reaction that you had was exactly the reason I did that follow-on work, which was at the end of my first work. I was like, wait, but this robot is just going to do everything I do. And we don't want that. So how can I tell the robot no? And the challenge in that problem is there's a lot of tasks that I do across my house, right? And the preferences of what I want the robot to do and not do are not tied to a whole task. Like maybe I want the robot to do a lot of cooking tasks, a lot of meal prep tasks, but just not coffee. Like that's very specific. So people's preferences, and I found that out with interviews as well, people's preferences of what they want the robot to do and not do are associated with tasks at a very granular level, but also in kind of an abstract manner. Like I don't want the robot to make coffee or do anything coffee related because I enjoy doing that. Or I don't want the robot to go near the stove because it's a safety hazard. So with that work, the way I ended up teaching the robot these ideas of what it should and shouldn't do is by giving it these explanations, right? If I'm stopping the robot from making coffee, my natural reaction is going to be like, no, don't make coffee. Like I like doing it myself. So the idea is if the robot gets that feedback, now it knows that it should make coffee and it shouldn't do other things that I enjoy doing myself. So that work is basically about how do you get a little bit of such feedback and then be able to generalize to other tasks. So don't go near the stove because it's a safety hazard probably means don't go near the microwave or the oven because it's a safety hazard as well. So that work is about taking a little bit of this feedback and then generalizing so that the robot effectively knows its boundaries.
Absolutely. This reminds me a lot about roommates and the tough conversations that we have each day with them. Sometimes it's not just what you say, but what you don't say, and also the body language and the emotions that go behind it. Is there a way for a robot to be able to read into our emotions?
I think that is a very interesting question. I think nonverbal communication is something, like you said, we do with humans every day. I don't think we are quite there with robots. There is a field of affect recognition in robotics, and what affect recognition aims to do is a person happy, sad, angry, disgusted, kind of right, like the basic umbrella of emotions. And like every other computer vision problem, if you have enough data, you can probably classify. The problem there, though, is when you're trying to interpret someone's nonverbal feedback as feedback to an action, that kind of set of 5 emotions may not be sufficient. You're trying to read into it in a more kind of subjective detail. So this sort of almost like a task-oriented emotion recognition, as far as I know, is not, at least it's not a mature field of research. So by task-oriented, I mean, am I just trying to gauge the person's reaction to watching television? Or am I trying to gauge their expressions as they do a task versus their expressions as they're trying to communicate something to me? So you kind of read people's reactions differently in all of these scenarios. And that sort of kind of context or task-dependent emotion recognition would be great to do, but I don't know if we're in that yet. And I think one big challenge in that would be getting the data, right? Given enough data, you can do the task, but getting interactive data is always a challenge.
Absolutely. And people have different ways of expressing emotions. At least that's what I know. So let's talk about how this field is growing. You started off with spatiotemporal object tracking, STOT. Could you talk more about how this works?
Absolutely. Yeah. So when I started first, we were thinking of like, okay, you're trying to model people's routines over long periods of time, and long periods of time could be like weeks, even months. So you're just trying to understand what a person's just overall routine looks like, and you need a domain to do that in. Like, how do you define the routine? Is it a list of activities that I brush teeth and have breakfast and then I go off to work or something like that? Or it could be my spatial location, which would be very specific for no reason. So you're trying to weigh out different modalities, particularly in terms of we were looking for something that is expressive of the routine, where we can actually find patterns, but also something that's observable. So something that a robot living with me should realistically be able to actually see, right? And something that's actionable. So meaning if a robot knows that I'm happy or sad, there's nothing the robot can really do about it. If the robot knows that I'm having breakfast, maybe the robot has some idea that, okay, now we're talking about, bringing you breakfast related stuff. But the reason we zeroed in on object movement is because it kind of fulfilled all that criteria. You can find patterns in object movements around the house, and that kind of reflects your underlying routine. They're more easy to observe compared to human activity recognition. Human activity recognition has all sorts of issues. One, just the actual pure performance of human activity recognition systems is just not quite there yet. Object recognition is way more mature as just like a perception problem. But also just being the robot being in a space where it can perceive the human action clearly is kind of difficult to do in a household. So it's really hard for the robot to see me take the milk out of the fridge, like in the act of taking it out of the fridge, because the robot would have to be positioned very perfectly next to me while I'm doing it. But the fact that the milk bottle ended up on the table is much easier to perceive. The robot has more time, more vantage points to be able to do that. So the idea of observing my routine through these objects just seemed much more feasible. And the bonus advantage is that now that if you're predicting in object space as well, which means the robot is predicting that the milk ends up on the table, then now the robot automatically has an action to do. Like, okay, I can move the milk to the table. I don't have to go through the reasoning step of she wants to have breakfast. She wants to have cereal and milk for breakfast, which means she'll need milk, right? So you kind of bypass the necessity of the whole reasoning process. So for all of those reasons, the spatiotemporal object tracking model was our first attempt at making a proactive robot. We said, hey, forget about everything else. Let's just look at objects in the house and nothing else. Objects and where they're located. That's it. Let's keep looking at that for days and days. And then have a model which can now predict what's going to happen in the future, again, in object space. So what this model can do is track all the objects in my house for a few days, build a model of how these objects are moving relative to each other, relative to time. And then at any given time, it can be like, all right, in the next 10 minutes, I expect these objects to move from their current locations to these new locations. And that is now a simple model where the robot can be like, okay, the milk needs to go on the table. And it doesn't know that it's meant for breakfast. It doesn't know that it's a thing I drink or any context, but it needs it has the information that it needs, which is milk from fridge to table. So,
yeah. Absolutely. And what if, you're a parent and your kid just messes up the entire house? This could be helpful, right? Because you're tracking objects over time. Just bring them back to their original location and keep things clean.
Right,
yeah,
absolutely.
I just thought about that. It's actually pretty helpful.
Yeah. No, that's actually a parallel research that not me, but one of my lab mates does, where we look at object tidying and how do you model people's preferences around where objects should be located. Yeah.
What happened after that? There was Slate Pro as well, and you introduced activity modeling. Can you talk more about that?
Right. So the idea around SDMT was to use object movements for all the reasons that I outlined before, but that doesn't mean that there really is no information in activity labels, right? The fact that that I'm brushing probably means that I'm not currently having breakfast. Like there's some information coming from activity labels, which we don't want to rely entirely on them because for all the other reasons, it's not a good source of information. But at the same time, we want to maximally use all the information that we have. So the follow-on work, Slate Pro, was saying, hey, it's great that we have objects, but what if we could also use activity recognition labels? Just how much ever benefit we can get from that additional source of information. So on a technical level, Slate Pro made two advancements. One was a little bit hidden because SDOT was a Markov model, which means it only looks at the current state to then be like, this is what's going to happen next. And obviously, there's all sorts of information you lose by doing that. What if I've already had breakfast half hour ago? This model doesn't even know. So with Slate Pro, we made it recurrent, so now it has the whole history. And then we also added this extra stream of information, which is, what if you also have activity recognition labels? So we modified the architecture to do both of those things. That is basically, the idea there was to improve prediction performance, right? At that point, it was a follow-on work. Yeah.
So in the vein of making the most out of information, how does sparse user feedback help? What were you trying to do there in your recent paper?
Do you mean the paper on personalization, or do you mean the Slate Pro or
the one that was the very recent one, but what personalization using sparse user feedback?
Right.
Taco, that one.
Yes. Yes. So Taco, I love the name. Taco is meant to start over. The most recent work on personalization was, yes, it was meant to use sparse user feedback. It was meant to learn preferences on where the robot's boundaries are, right? And I think, kind of like you mentioned before, one of the most important things in my work are the fact that the robot shouldn't be bothering the person too much. So unobtrusive and like limited interaction are kind of core to my work. So far with SDOT and Snake Pro, it was mostly unobtrusive observations, because fundamentally what we're trying to learn is, what does this person's life look like? And what this person's life looks like is the same thing whether or not the robot exists. It's observable by the robot as a bystander, as not playing any part in this whole situation. That gets a little tricky with something like Taco, where what Taco is trying to do is understand what the person wants the robot to do. So this sort of preference doesn't exist in isolation without the robot being there. So now it's really hard to do this completely unobtrusively, where the robot is almost invisible and just, not playing a part, because the preference kind of originates from the fact that the robot is there. So what's the next best thing we can do is, yes, we ask the person for their preferences. Well, we do it in a way that we can use as little feedback as possible. So the sparse feedback idea is, we have thousands and thousands of tasks the robot could do across the house, but from only a handful of tasks, or feedback on only a handful of tasks, can the robot then generalize across all of these tasks.
That makes sense. And there was also something about explainability, explaining one's reasoning. Yes. Okay, why did you do this task? Can you talk more about that? I'm really interested in this, because there's a time and place to explain something, and I'm trying to understand, when is it the perfect time for a robot to explain their actions to a human?
I think the easy answer to that would be when the robot is asked a question. Right. I think it would. I mean, this isn't something that I want to make a claim on without, doing a study about it. But at least for now, most of the explainability that I focus on is, okay, does the robot, right, at any point in time for any action have an answer which it can then give if asked? So I have not looked at when to provide an explanation so much, which other people have, to be fair, in the field. For me, it's been more about, do I even have an answer if I'm asked a question?
Yeah. It's that makes sense, because you never know when you're going to be asked the question.
Yeah, absolutely. And I think that something like proactive behavior, or any of these behaviors where this robot has so much level of autonomy that it's making all these decisions almost like without any input from you, you're going to have a lot of questions. Like, hey, like, why did you do that? And the robot's going to go wrong. Like, the robot's going to be wrong sometimes. Like, that's unavoidable. Something's going to look weird to you as a user. So I think explainability is extremely, extremely crucial as robots become more autonomous, more proactive, get more agency in that way.
Yeah. Something I keep thinking about is, you alluded to this in the paper, where, human-robot collaboration in a factory setting and human-robot collaboration in the household environment, they're two very, very different things. We talked about agency already, but what are some other factors that you have to consider when you're switching from one domain to another?
Yeah, I think so. I agree. I do think that they're fundamentally different, because a factory worker in an industrial environment has a role. It is not their space. It is a public factory space. And the intention of that whole, the human, the robot, and everything around them is towards a certain production goal. It's towards the factory's interests, or whatever that is, whether it's an assembly line or manufacturing. It's about that throughput, right? It's the person's, what you're trying to optimize is, how much of this do we do together as a team? And person's preferences do come into play there to a certain extent, because workers are going to have different ways they like doing an assembly, because they are faster that way. Their brain works better that way. But all of that is kind of a means to the end goal of producing this thing faster. In a home, nobody cares if the robot makes your cereal in like 10 seconds or 5 minutes. That's not the goal, right? The goal is, what do you want? The goal is, what kind of cereal do you want? When do you want it? How do you like it? Do you want to do it? So I think the main difference is the fact that the whole objective function really is no longer a very measurable outcome, but it's about what's inside this person's brain. And it's literally what this person wants. And it's a private space. So there are no universal cultural norms that will work in every house. So you're trying to adapt to this very specific private space, which has its own norms, and you're trying to fulfill this objective also of whatever the person wants.
Yeah, it's such a delicate balance because this is not about getting the task done as soon as possible, but like you mentioned, you have to manage their expectations, their preferences.
Yeah, exactly. And sometimes it's not even about doing it as soon as possible, like meal prep, right? If you're doing meal prep with the person, if the robot just like finishes the whole thing, the person's like, yeah, but I was going to, enjoy doing this. This was my Sunday afternoon. So sometimes that's kind of the opposite of the point.
Yeah. What are some ways in which robots can build deeper relationships with humans in a household environment?
Yeah, I think that's almost an ethics question. I mean, anything that I say here is going to be kind of my personal views that could be biased by my preferences. I think of robots as mostly functional agents, which will end up being social because they're just a part of your life. So, and again, these are particularly the robots that I work on. There totally can be purely functional robots or purely social robots, but the robots that I think most about in my work are these sort of balance where this robot exists primarily because it has a function around the house. It's going to do household chores. It's going to do just kind of different tasks that are physically grounded in this environment. But because the robot is doing these tasks for me, there is going to be an interaction component. So how do you converse with the person? How do you understand what they mean? How do you explain your own thought processes? There's going to be all of these interactive components. And because those exist, obviously a social component exists. I think as to what that means in terms of the human-robot kind of relationship is that's going to be determined by a lot of factors. I think it at least has to be a sort of trust in the sense of like, I trust the robots to be around me, be around my house, do things for me, right? That's kind of the baseline level that I would want to establish. Personally, I would also want to establish a ceiling to that, which is this is a robot that is meant to do domestic chores, that is meant to help, but not become something that I rely on for more than household duties. Again, this might be a preference that is mine personally, but I think these are the questions that robot designers will have to ask. Like, what do I make my robot look like? If it's going to look like a human, people are going to be attached to it more than if it looks like a literal robot or like something that's very not anthropomorphized.
Right. It's a complicated question. I remember asking your advisor one time in class that what's a healthy relationship? Because it's hard. You don't know what the boundary is. And sometimes even when you say that you have a boundary, you might not actually adhere to it. Maybe your subconscious believes something totally different. So it is a complicated question. I feel your job as a researcher is going to be very messy because you're dealing with human relationships now.
I agree.
Just saying.
Yeah, warning taken.
Yeah. A big part of your future steps is trying to deploy this in the real world. But before that, it's also simulations, validating that this works in a closely bounded environment. And that's where Homer comes in. Can you talk more about that data set and what you're trying to achieve?
Yeah, absolutely. So the Homer data set was meant to enable all my research on proactivity. The core component of that research was being able to predict human behavior and to be able to do so over several minutes to hours and to have the data to train a model, which needed more than that. We needed several days or several weeks of behavior. Now, the other constraint on that was we wanted this data set to have very specific details. So kind of like you talked about SDOT and SlatePro, the observations are talking about single kind of object movements, like the milk in the fridge, the table, right? So unfortunately, because this is kind of a very underexplored field, there really wasn't a data set that had both of these properties, which is that it went on for days and weeks and months, and that it had the level of detail that we needed to be. So for context, most of accurate recognition work would happen in visual domains where the data sets would be a few minutes, right? I'm making a salad and that's the data set. So it wouldn't have this property of going on for days and weeks. Therefore, there's the other extreme where you talk about wearables or you talk about smartphone sensors. These data sets can be really long, but it doesn't have this kind of object level detail or this kind of scene context that we need. So the point of Homer was to have a data set which reflects realistic noise in people's routines, but has these properties of having object level detail and be longitudinal. So the way we did that was we crowdsourced some information. We asked people, here's a set of high level activities like brushing teeth, having lunch, watching TV, and so on. And can you tell us when you do these activities? We kind of processed that into a probabilistic model or a set of probabilistic models of what a person's temporal routine looks like. And then we had a different set of people fill in the blanks, like what does having breakfast look like? Tell me in object level detail, like moving milk, moving cereal. So essentially, we started with the crowdsourced data. With this sort of processing, we ended up with like literally a list of here's 50 days in the life of this fictional person. Yeah.
That makes sense. And what about Habitat Sim? You worked on that recently at Meta. How does that connect with some of the work you've been doing with Homer? Is there a common theme?
Yeah, to be clear, I'm not personally involved as much in Habitat directly, but yeah, I think Habitat Simulator is one of the really good robotic simulators that now has people and you can model human-robot kind of collaboration tasks and all sorts of things. I would think of Habitat and something like Homer almost as complementary. I chose to use Virtual Home for Homer for logistical and practical reasons back at that time. I think Habitat did not have Habitat 3.0 when I had Homer at all. But the point of Homer was not the simulator so much as the data itself. So what Homer is trying to do is this is what a person's life looks like. And what the reason I say it's complementary to something like Habitat is because once you have this data, you can process it and expand it in a simulator. Instead of this textual data, you maybe have robot observations of this data, or you can basically get this data projected in all sorts of modalities, whether it's robot observation space, whether it's human observation space, or all sorts of things.
Okay, now my favorite question. Can you talk about the simulation to reality gap as we move these into real world settings?
Yeah. So there's a good thing and a bad thing about it in context of my work. That is, my work exists on an abstract enough level where the fundamental definition of sensorial gap has always been in context of like visual observations. Like Habitat is good a simulator as it is. The cabinet in Habitat is never going to look the exact same as the cabinet in my home because all sorts of like visual artifacts, lightings, textures, so many things. Fortunately, because my work is a little bit more abstracted, that is, I rely on a base perception layer of like, oh, something needs to tell me the fact that the milk is on the table. And I'll take it from there, right? So the fact that the milk is on the table, fortunately, is the same whether it's in a simulator or the real world. So that's the good part. The hard part is because I work in a simulator or on data sets, I conveniently go around the idea of partial observability, the fact that robots may not observe everything constantly perfectly. Particularly, a big assumption in my work is that we say that the robot has access to these object observations and how objects are moving over time, which implicitly assumes that the robot knows exactly when things move. Like, by exactly, I mean maybe with like a 10-minute granularity. But even at every 10 minutes, it's kind of impossible for the robot to keep track of everything in a whole household. So maybe the robot realizes 30 minutes later that I put my coat in the closet or something, right? Maybe it didn't like happen to see that. So that's one. That's kind of a big assumption that is the sim to real gap or something like my work. And yeah, like you alluded to before, we do plan to put this work on proactivity in the real world. And yeah, stay tuned for more on that. But the idea is to see without this assumption of perfect observability, how these robots can even model routines and how good these routine models look like when we take all assumptions away from what our data set is, right? Like Homer, even though we had crowdsourced data and visually we inspected these data sets to be like, yeah, this looks realistic, right? But it was still a data set. So with no constraints, the idea is in real lives, people are going to behave in ways that, honestly, I don't know. I'm expecting to see things I never expected. So with basically those main two things were imperfect perception and very, very natural human routines, you're going to try to deploy a robot and yeah, we'll see how it goes.
Yeah, good luck. How does this get complicated in multi-user settings when there's more than one person in the household and you need to, make sure everything
Yeah,
runs smoothly?
that is a great point. So the deployment that I mentioned will also have multi-user. So we'll find out the answer to that question as well. But I think so fundamentally, SDOT for one has no limitation because it never even sees a person. So it really doesn't care how many people there are. Slate Pro has activity recognition, but at kind of the core level of the model, the fact that it's an activity label is just, it's a human interpretation. The point was to have multiple sources of information. And these sorts of information could look like a set of activity labels instead of one activity label, or it could look like how many people are there in the room, right? It could be any alternative source of information that you think is useful. So the reason we're thinking of doing this in a multi-agent setting, kind of relaxing that assumption as well, is because none of our models are fundamentally limited to the fact that there's only one person in the environment. That said, so far we've not tested these. Homer only reflects a single person's routine. So far we've not tested these models on multi-agent settings, but I guess we'll find out soon.
Yeah. It's interesting because what if you mess up one prediction? Could that have, does that mistake roll over to other users and does the entire system break? I don't know. Like you said, we'll find out. I'm curious. Let me know.
We'll find out. Yeah. Yeah, absolutely.
I wanted to end this conversation around the theme of loneliness and how that could be a huge issue. It already is a huge issue, but as we get older, there'll be fewer people around. I think houses are getting bigger, the families are getting smaller. There will be a need for robots around elderly people. How does proactive robot assistance help in such a setting?
Yeah, absolutely. I think that yeah, that's going to be a problem tomorrow. There's a problem today. If you're getting growingly more isolated, that is a massive concern. Um, I think I think loneliness. Well, to be clear, the best way to combat loneliness is to build social relationships and to actually live with other people. But I think, short of that, people address loneliness in many ways. Like people associate with podcasters, people associate with TV shows or characters on TV shows. Now, the reason I mentioned particularly these kinds of relationships is because they're one-way relationships. They're not even a two-way relationship, but somehow it helps people think of themselves as not being alone. So I think there's various ways that people can address loneliness, and I think robots will play a role. The reason I mentioned this whole spectrum is that I think robots should play a role somewhere on the spectrum, but I think we as robot designers need to be really careful that the importance of the robot's role does not get very close to the actual personal interaction end of the spectrum, because there's a real danger there. If people start relying on robots to actually alleviate this sort of loneliness, there's a chance that people stop wanting to build personal relationships. And yeah, this is a dystopian scenario, but there is a scenario where because the person has relied on a robot for so long, you go down this path of not having people around you because you had a robot to substitute for that. And there might be a sort of, not a point of no return, but a point where it's really hard to return from and go back to having personal relationships. So I think it's a very delicate balance of that. Yes, you want robots to be companions, to help people with social interaction, loneliness, but at the same time, not have people be reliant on robots for that. Some other ways where robots can actually help is to explicitly help people connect with people. Like a proactive action could be like to an elderly, could be like, hey, do you want to give your daughter a call? It's her birthday, or something like that, right? So I think that is not my research again, but I think that there's a very huge potential for robots to actually play roles as mediators or as a companion that can still cement your relationships with other people. So yeah, I think there's immense potential, but I also think that means there's immense responsibility on people who are designing these robots.
Absolutely. And, there's going to be a group of very talented AI researchers, roboticists coming into universities now, and you're at the end of the journey now, close to being done. What advice would you give, budding AI researchers in terms of the problems that they choose and how to navigate through these next 5, 10 years? It's going to be a long journey, so I would love to hear some of your lessons learned.
Yes, it is. Yeah, it's definitely a long journey. And the answer to that question is it's hard today than it has ever been, and it's only getting harder. The way the field is moving today is not something that we thought would happen even when I started my PhD, to be honest. We didn't have language models when I started my PhD. So just through these the last 4 years, things have changed in massive ways. Um, which is in some ways good for the technology that we have these very, very capable models to do a lot of things that were just genuinely really hard to do before. But for a researcher, that just makes life a lot more complicated because just your notion of how to solve problems seems to almost change overnight on the research timescale. And yeah, so I think a lot's changing, and I think if you look at the low level, it just feels like it's impossible to make sense of this research landscape. My primary advice to new people would be to not be scared about that, to look at the upsides, right? And to kind of take a step back and think about what they want to do. Like, I think the most important thing when you're committing to doing something for 5, potentially more years is that you genuinely enjoy it. A PhD is fundamentally intrinsically motivated. You don't have a boss getting updates from you every day, at least hopefully not, for the most part, not. So you have to be really motivated to work on whatever you've chosen to work on. So choose wisely, choose a field that truly interests you. If it takes time for you to decide what that is, that's okay. If you have to switch a couple times till you find what really works for you, that's okay too. So pick the field that works for you. Pick an advisor that works for you. Pick an advisor whose style matches yours, who you can communicate with, because this is the person that you're going to constantly work with for the next 5 years. Yeah, so these are big commitments. So it's always nice to make that choice wisely, change as much as you want till you find your right match and not worry about that. But once you've found the field that really interests you and you work with a person that you really enjoy working with, it's just different. It's really rewarding. Yeah.
Yeah, yeah. And the proof is in the pudding. You've clearly committed to something, and it's really wonderful to see that, your work really has a broader impact. Over the years, this is going to be such an important question about what it means to be human. Much admiration to you. I hope you keep working on this field, and I wish you the very best.
Thank you so much. No, I really appreciate the words. Thank you.